Hi, my name is Greg Lazenby. My partner is Rebecca Holzapple. As a commercial pilot and engineer in the aerospace industry, I'm pretty much fascinated by anything aviation related. So here we're predicting flight hours. This is an important factor for commercial airliners for many reasons related to crew scheduling, aircraft positioning, and training. So our data set comes from the Bureau of Transportation Statistics, specifically carrier on-time performance data set. We extracted several variables recorded across time, but focus here on flight hours, or what they call airtime. We filtered our data to American airline flights originating out of DFW during calendar year 18 and 19. The realization shows non-stationary behavior. The data was aggregated daily and displays pseudo-periodic behavior with period 7. The troughs are associated with Saturday, while the peaks correspond to the beginning and end of the work week. The autocorrelation shows a spike at lag 7, and the spectral density provides evidence of a period 7 with a peak at 0.14. The autocorrelation has some interesting spikes and pairs as shown here, which repeat every 7. We begin by trying to identify the model using AIC5, and both AIC and BIC criteria scored an ARMA 2.2 model as the lowest. However, this model just didn't fit very well. The factors didn't line up very well with what we saw in the sample plots, and the residuals did not appear stationary. So we moved on with modeling the suspected 1 minus b to the 7th seasonal model and generated factor tables for a pure seasonal model and an overfit factor table with p equals to 10. As shown here, the 1 minus b factor was the strongest, but the other factors quickly dropped off. The factor shown here was particularly far from the unit circle, and we didn't think this matched well with a 1 minus b to the 7th. Since we did see that dominant 1 minus b factor in wandering behavior, we decided to difference the data, and it appears to have stationarized the data. We ID'd the model with p equals 0 to 10 to capture the suspected seasonality of 7, and both AIC and BIC scored an ARMA 8.1 with the lowest score. So we moved forward with that and modeled an ARIMA 8.11. Here we see the system frequencies match up much better with what we saw earlier in the spectral density, and the residuals show all lags removed. The realization appears stationary, although there does seem to be some correlation remaining, and it did fail the white noise test using the Young box test. However, we felt there may be still some usefulness with this model, and here we forecast the last 20 days. The ASC is shown here along with the final model. Our future strategy includes plans for attempting to better model this kind of moving lag 7 here, maybe with a signal plus noise model.